Good afternoon. Let me just take the temperature of my audience here since this is a thermal discussion. How many people in the room have actually used a thermal camera? Not just seen imagery, but okay, a lot. Well, that's a good thing because at FLIR, one of our goals as a company is to expand the usefulness and the awareness of thermal imaging significantly. I'm going to spend my time today talking a little bit about the history of the Zenmuse XT and how it came to be. But I want to start off first by saying, acknowledging DJI, first of all, for sponsoring this event. This is a really important event, I think, because we're in the midst of a revolution in industrial imaging, thermal imaging for sure, and how these things are coming together in a confluence to really start providing solutions to these applications that we're talking about. I also want to, it was about a year ago, I think it was just a little less than a year ago, I think in December, I was working with here in San Francisco when we presented the introduction of the DJI Zenmuse XT. And it's amazing, as Michael pointed out earlier today, how much things have changed in the expertise of the audience and the know-how of this technology. I'm going to tell the story a little bit about another reason I want to acknowledge DJI is much more personal. When I was in the late 60s, early 70s, I was as a hobby, I was very much into things that flew. Things that flew and things that blew up were kind of the two things that I was really engaged with. Actually, if they did both things, that was the best. If they flew and blew up, that was really, really good stuff. So I started off with Estes rockets and fired rockets off, and a few years later I started getting into fixed-wing aircraft and RC and the glow plug engines and flying these things around. And as time went on, I kind of continued to work my way up through the technologies and ultimately got into rotary wing aircraft and started trying to fly those things. And that started off with the experiences like many probably of you had went through during those times of your life where you buy the first one, you buy the kit, you put it together, you take it out, you fly it, things happen. Rotaries were very interesting devices. They were complex, they were hard to put together, and I went through this over and over again. And this is a fairly typical example of my experiences as I would go out and have these things. Now that went on over and over again, and that tells you a couple of things about me. One is I'm persistent, but the other one is I have very few motor skills with respect to being able to fly these things. But that all kind of changed for me. And things went on. By the way, I continued to try to do that, but the problem is it kept getting more and more expensive as time went on. And so it wasn't until early January, February 2013 that my world I went out and I bought one of these things. And I took it home, read the instructions, pulled it out of the box, charged the battery, walked out in my front yard, flipped it on, flew it, waited for it to crash. It didn't. I actually flew it for about 10, 15 minutes. And for the first time in my life of ever being in any of the rotary wing stuff I'd ever done, I actually got to charge the battery for the first time and go for a second flight. That was pretty profound for me. I mean, it was actually very profound. And what happened then was all of a sudden this word drone for me took on this new connotation, which is this is really a fun toy and it really, really works. It really opened up my eyes to where to something that I really enjoyed, and it really was something that I had done most of my life. Eventually I did crash it, and I did have to go out and buy something new, and about that time the Vision Plus, or the Vision, became available, and I bought one of those. And similarly, went outside, flew great. But now, for the first time, I was able to do something that I had never done before, which is actually take pictures from the air. And it was this camera that really intrigued me. Now, I obviously had the opportunity to integrate a GoPro onto the original Phantom and that sort of thing, but I had never done that. This was really my first experience with flying a camera. And this experience really did a big thing for me, which was changed this idea that these drones are just toys that really work, and really took it to, this is really a fun flying camera. this thing is actually really useful. I can use it. It's not just something that I'm going to go out and get, have fun with because I can fly it, but I can actually start doing things with it. Now that's my weekends. That's what I do on the weekends. Then I have to go back to work on Monday morning. So I go back to work. I go back to work at a company called FLIR Systems. It's a pretty good place to work. We're about a $1.6 billion revenue company, about a $5 billion market cap. We're based here in the United States, but we're very much a global operation. We are the world's largest supplier of infrared devices for the commercial use. We also deal in the military too, but in terms of the commercial world, we are by far the largest. We work across multiple business segments, and I'll talk about that in a few minutes. My job in the company, amongst other things, is one where I kind of look out at what we call Horizon 3 opportunities. Horizon 3 being the things that are not really focused this year or next year, but things that are going to start affecting us 3, 5 years, maybe even 10 years out. What can we be doing as a company? Where is this technology going? Where are technology vectors coming in that are going to influence the future of our technology and what we're doing? And I sat there that morning and a few days afterwards, thought about my experiences over the weekend. And this concept clicked with me that, in fact, the drone wasn't just a fun flying camera that really works, that it really was, in fact, a way to position a sensor in 3D space. And we're a sensor company, so this is important. Now, we as a company, this concept of positioning our sensors in 3D space isn't new. We do it, I've actually done it for quite a while. We build sensors like this. This is one of our higher-end gimbal products that we sell. This thing has approximately 6 or 8 sensors, well, 6 sensors in it in this particular version of it. They range in price from about $500,000 to $1 million, depending on what sensor options you put in them. They're very, very high performance, lots of capability. They get mounted mostly on manned aircraft, both fixed wing and rotary wing. Most of the applications tend to be military, so they end up in solutions like this. These do get put on, or variants of these do get put on unmanned vehicles. So again, unmanned vehicles isn't necessarily new to us. It's something we've been doing for a while. We also sell camera cores, the bits that go inside that form the technical heart of these larger sensors in it. And those camera cores we also sell to customers outside of our company who integrate them into various applications. And when I was sitting there in about the early 2014 timeframe, we were selling a number of, actually a lot of these cameras into, again, mostly military applications. The AeroVironment Raven is one of the examples. They also have a product called the Switchblade. So our cameras were going into these. So again, we weren't necessarily new to this space. We had been doing this before. So if you look at our business segments, most of that stuff I just talked about was in our military segment. And if so, in terms of application of drone technology or airborne, the idea of using these in airborne, that actually wasn't necessarily a new concept. This is something that we had been doing for some time. But we as a company, we have more business segments than that. We actually have businesses in commercial security. In this area, think about things like airports, dams, nuclear power plants, anything like that is where we'll sell security cameras, both visible and thermal cameras. We have a maritime business. Maritime might seem a little bit weird, but actually, if you think about thermal imaging, and infrared imaging, it's very powerful, very useful in maritime applications because now you can see at night on boats in that area where you wouldn't normally have it. We have a commercial instruments business. This is our second largest business, as a matter of fact, that is involved in building inspection, industrial predictive and preventative maintenance, critical infrastructure, oil and gas, old pipelines, all of those kinds of things. These are, and we build systems and complete solutions to go into this, and also firefighting it was one of the segments here. And we also have a detection business that's involved with chemical, biological, radiation detectors, that sort of thing, that goes into applications like transportation safety, first responders, and that sort of thing. And we also have a horizontal business that we call our OEM and emerging business. This is where those cores that I talked about are built. So we sell those to third parties. Anybody that wants to buy the cameras or the sensors can buy them from there. And then we also have an emerging business there where we do kind of the new things that we're bringing into the market. This is the incubator for that. So as I looked through this portfolio, and I started thinking about my experience and that revelation I had that this new technology came along that was a way to position these things in 3D space, I said, what if these things were actually, instead of these large, super expensive things that we build right now, if they were small and portable, if they were ready to fly, if somebody could take it out of the box and actually fly it, like the experience I had that weekend, that it was easy to fly, like the experience that I had that weekend, and that it was in fact safe to fly, and most importantly, if it was affordable, then what could we do with it? Then now where are our opportunities? And it turns out, if you start to map that, it is a pretty big chunk of what we do. And I'm sure this is probably true in many of your businesses and many of your business ventures, that when you start thinking about combining these technologies, they're going to have a big impact on multiple aspects of your businesses and how they're executed. Now, I'm going to step back a little bit and talk a bit about the sensor technology specifically, because I'm talking about sensors here. And I'll start with the kind of the traditional, electromagnetic spectrum here. Now, our eyes, we're equipped with a set of sensors on our bodies. Our eyes are our visual sensor. Those are actually active and work in a very, very narrow set of the electromagnetic spectrum, the visible region that ranges from about 400 nanometers to 700 nanometers. This is where our eyes work. Our company does sensors that are involved in gamma rays, ultraviolet, radar. We actually do a lot of work in the visible world, and we're just now starting to venture into some of the RF world. So we build sensors there. But 70% of what we do is really in this infrared region. Now, the infrared region, you have to understand it a little bit. It breaks into a couple of subsegments. And I don't want to go into a lot of technical detail here today, but I think it's important to understand a few elements of this. First of all, there's the near, the short wave, the mid wave, and the long wave segments of the electromagnetic spectrum that range from the 700 nanometers up to the 1200 nanometers. Now, it's interesting that in the near infrared area, and going into the shortwave infrared area, really relies upon reflected light. Just like the visible spectrum, if I shut all the lights off in this room, your eyes stop working because there's no reflected light in the room anymore. Same thing is true in the near infrared and much of the shortwave infrared. Even though this is nothing in these wave bands can you see with your eyes, they still require some reflected energy in the scene to do that. Now, interestingly, the sensor in the near infrared side to sense that is silicon, and silicon is the same sensor that is in your camcorders, in the DJI drones that you're buying, in the X3 and the X5. All of the sensors in your cell phones, those are all silicon sensors. Those all actually have the ability to detect these wavelengths. Many of them are filtered out, so they don't, because they can create some unwanted effects. But if you, in fact, want to look in those wave bands, you can filter those sensors into that. A really good example in the drone world and where that's being exploited right now is in the red edge side of things. I'm sure many of you are familiar with that, where that's into the near infrared band in the 800 nanometer, 750, 850 nanometer areas, and that's where you put a filter into that area, and now you have this red edge technology. Now, starting around around 3 microns, a little less than 3 microns and above, things kind of change now, because now no longer is reflective light necessarily the dominant thing. We can still see reflected light in those wave bands, and we obviously do still see reflected light. But it turns out that everything that's above absolute zero is either radiating or reflecting infrared energy, which means, unlike the visible band, if I shut all the lights off in this room, all you people would be glowing like little light bulbs because you're emitting infrared energy that is easily detected by this technology. Now, the sensors for this technology are not silicon. They're much more complex. They're much more esoteric, exotic semiconductors. Things like in the near-infrared band, indium gallium arsenide. In the midwave bands, indium antimonide. In the midwave and long wave, mercury cadmium telluride, quantum wells. Very exotic, complex semiconductors, exotic semiconductors. Also in the long wave, there is another technology. It's a MEMS-based technology. Many of you may have heard of it. It's called microbolometers. That's available in long wave. It actually works in other bands too, but that's really where it's optimized to work really well. Now again, all of this area that I'm showing you here is is in a waveband where your eyes are, and none of your senses actually provide much, well, your touch, you can actually feel heat you're a thermal detector and that, but visually, none of this is available to you. These are all the technologies, everything in this area that I'm showing you here are things that our company does, and it's things that we're interested in figuring out how to exploit. But specifically the thermal band, I want to talk about that a little bit, because that's really the key of what we're doing here. What can it do? Well, first of all, with thermal imaging, you can sense very, very subtle temperature differences, down to 0.05 degrees. If I walked up to this wall, touched the wall like that, I would have just changed the temperature of that wall by more than by significantly more than the 0.05 sensitivity that these cameras have. You can see that by this picture of the handprint on the wall. Literally, that fast of a touch will change the temperature of the wall to where you can visualize that handprint. Also, things like in building inspection, the ability to see very subtle temperature differences caused by insulation differences in the building or heat loss in the building. You can see over in the next one over, the studs behind the sheetrock and a wall. Now, you can't see actually through the sheetrock. You can't see through it. Many people have that misperception about this technology that you can see through walls and that sort. You cannot. But what happens is that the heat capacity of the studs behind the wall are enough to change the surface temperature of the wall, and so the studs become very, very apparent. And then in applications like electrical, where even have a small difference in resistance from one conductor to another generates even a small rise in heat, you can start to see those things very quickly. And those things very often become indicative of a failure that's pending or something that's going to happen. Another key application for thermal imaging is being able to see in total darkness. I've already mentioned that you're all light bulbs glowing in this waveband. We all are. Animals are. Pretty much all objects, like I said, are either emitting or reflecting thermal energy. So it's very, very difficult to hide from, to cloak yourself in this. And it's also very easy to detect differences, especially against backgrounds like you see here. A forest background, because the temperature of the body is generally much higher or different, I should say, I want to say higher, but different than the background. So, and since we've got sensitivities that are down to 0.05 degrees, it doesn't take much difference between you and the background to be able to have you stand out. This is a very, very powerful value proposition for thermal imaging. Another value proposition, an important one, especially in the markets that we're talking about here, is the ability to measure temperature remotely. If I can look at an object and from 20 feet away or 50 feet away or 100 feet away or 200 feet away, be able to tell the temperature of that object, that really opens a lot of applications up. Now, Mike Kent, tomorrow, one of my colleagues, is going to be giving a presentation on thermography or infrared 101, and I would suggest if you're interested in learning a little bit more about this, you go learn that tomorrow, because there is some complexity with regard to measuring temperature in a UAV application, and he'll go over that. But the bottom line is we build cameras that can sense temperature differences down to about plus or minus 2 degrees remotely, depending upon the environmental conditions, and then very accurately, if you're not caring so much about the absolute temperature difference, but the relative temperature, the difference between one temperature in the scene and another temperature scene, it can be quite accurate in that case. Another value proposition is seeing through obscurance. I know there's a few firefighters in the room. I saw on your badges, we've got a few firefighters in the room, and you guys are well familiar with this application. We sell a lot of cameras into firefighting in very many different aspects of our business. Imagine walking into a smoke-filled room where you can't see the hand in front of, a foot in front of your face, being able to take one of these cameras in and being able to cut through the smoke and see everything through the smoke. It's an incredibly powerful value proposition. Same is true for dust applications. So think about landing in a dust or trying to image through a dust-filled environment. There's also other obscurance. I told you before you couldn't see through walls, solid objects. But thin solid objects, you actually can see through in some cases. I don't know if anybody recognizes that. So that was imaged by one of our cameras. This was the boat that the Boston bomber was hiding in. They had a rough idea of where he was. They knew he was in a neighborhood, but they didn't know where he was in the neighborhood. So this is the Massachusetts State Police, have one of our gimbals mounted on their helicopter, flew through the neighborhood and saw this guy through the plastic that was on top. So very profound, very compelling application of being able to see through obscurance. And one other one I'm going to just spend just a moment on is this idea of ability to reveal invisible gases. Now, not all of our cameras do this. It takes special configurations of our cameras to be able to have this capability. The image on the right is the Porter Ranch leak that happened in Southern California. That massive leak occurred there. But you can see with this guy filling up his gas tank where there's not a vapor recovery system, that even subtle small gas leaks become very obvious and very visible. I think there's tremendous opportunity in drone applications and putting this kind of technology on those systems for oil and gas applications and environmental monitoring. So with all of this, all these applications, these value propositions, this new emerging opportunity, I sat and thought, what am I going to do? I've got this really cool technology. I've got this really neat drone that I've got. How are we going to bring these things together? I thought the only thing I can do is hop on a plane, and I flew to China. And knocked on the door at DJI and said, with my camera in hand, and said, I've got a camera. And first time I went there, they said, oh, you got to go talk to our distribution guys. And they sent me over to the distribution guys and took 2 or 3 trips over there. But finally, I made it to the right folks in the company and told the story that I just told you. Here's got some really cool value propositions. You put these things on drones. I think that there's going to open up some new opportunities. Now, at the time, all I knew about was the Phantom. That was the only thing I had any insight into. Obviously, the Phantom has had some issues because it's small, it's fairly lightweight. We do have cameras that would probably fit on that and work well, but it was small and it was probably marginal. And also the fact that that was very, very tightly integrated with the camera on it would present some engineering challenges in the early phase. And they brought out and they showed me this thing, and I think I might have been one of the first people who had actually seen this. This was before it was introduced. And we started talking about the fact that this thing had a removable bayonet, and it was really maybe this is a place where actually it might be a good target for it. And at this point in time, by the time that meeting finished, I walked out of there, and at that point, the drone had become a way to position a 3D sensor in space to become a very powerful tool when I saw what these folks were doing with the direction that they were heading with the drones and the technology they had. We've really had a really super powerful tool now. Now, since the old adage is that if you're a hammer, everything in the world is a nail, this is my view of the world. I think that probably the DJI guys were looking at it a little bit differently, thinking that thermal is a new sensor that will really provide a really good new value proposition to drones. But whatever it was, it resulted in a strategic collaboration that continues to this day. At that point, it generated the Zenmuse XT, which I think many of you are now familiar with. This is, again, the result of a very strong strategic collaboration we have with the company. And we're very excited to be part of this. The market has responded as well. There are now many thousands of these cameras out there on drones flying. And I get some insight into the applications that are coming out of these. And it's pretty amazing. I mean, there was a lot of things that we expected to happen. Yeah, people are going to use this for roofing inspection and electrical utilities. But things like ideas like accident forensics at the time, I didn't understand the value propositions around thermal in agriculture. I've since become aware of those things. The bottom line is we're now seeing dozens and dozens of new applications for this technology with very, very strong value propositions. So here we are today, 2017. In my sense, we're sort of at a turning point. We brought a new technology out with DJI. It's being used, and it's being used very effectively. But there's a lot of opportunity, I think, for taking this technology and the combined technologies and other technologies and the whole ecosystem and bringing it together in ways that are going to be much more powerful. You look at some of the market data, and I don't know if I'm not going to bode for the accuracy of any of this market data because there's a lot of it out there. It's very varied. But there are a few threads that I've seen recently This is one that is indicating the direct economic impact of the UAV industry in the United States coming up. And there's a profound, I think it has a lot to do with the 107 rules, the regulatory environment, but very much driven also by the solutions that this group is bringing into the world. There's a step functions that are occurring in 2016, 2017. Another piece of data I've seen is the commercial market going from 600,000 to millions of units in the commercial market space. Again, I don't know how accurate this data is, but I think I've seen this thread fairly consistently, and I think just by virtue of this group and the people that are getting together here and the technology convergences that I see with DJI and the other participants and the other presenters today, I really believe that we are at a turning point. We are at an important juncture in this business. From my perspective, from the thermal business, if I take that data, and again, this is the same set of data, what are the top 5 places where these technologies are going to be used? If I look at those and I say, where can thermal imaging, will thermal imaging play a role? It turns out in almost all of them. The only one I won't lay claim to is the real estate and the aerial photography businesses. But I think insurance, absolutely. Roofing inspection after disasters, that sort of thing. Agriculture, I think, is obvious. Ray will talk about that in his presentation tomorrow. Industrial imaging, lots of examples of that in the presentations that I heard today, and certainly for sure in government. So the top markets, I think thermal is going to play a very large and important role. I'm going to close today with I think this has sort of been the thread of most of the presentations that I've seen, but this is not one company, not one technology, not even sets of technology that are going to come together that are going to make this happen. It's really an aggregation of things, of ecosystems that are going to come together and make it happen. On the airframe side, there's a tremendous amount of work that's been done and a tremendous amount of work that needs to get done to make airframes safe, flyable, accessible, cost-effective, all the things that need to occur, and I clearly believe that DJI is leading that charge. On the sensor front, we certainly like to believe that we're playing a role there, but certainly the LiDAR work that Leica is doing, there's a tremendous amount of other work that's going on, all of that sensor technology coming together. And then really super important is the software, the solution software piece of this thing. All the photogrammetry, all the things that have been talked about today, all those pieces need to come together. And it's the bringing together of all of this stuff that is really going to exploit the opportunity, the adoption, the acceptance, and the growth in this business. I'm just going to show you one little quick video, very short, of an example in our world, in the thermal world, where that's sort of starting to happen. This is some imagery that Pix4D has took and processed. But this was the first output that I've seen where they're using this Zenmuse XT to actually generate 3D point clouds of thermal information. Now, this one isn't fully radiometric, but you can imagine very soon we'll be in a world where the 3D point clouds, every point in that cloud is not just going to be an RGB intensity level, but it's going to be a temperature. And when you have that, I think it's going to be really powerful next step to creating new applications for this. Finally, the work that Rob and his group presented this morning with regard to the SDK work, in my opinion, is the huge glue that's going to really bring all this together. The SDKs and making this technology, putting that glue in between all of these various things such that the developers and you people can actually start to create applications is where the magic is really going to start happening. I'm super happy to have been offered the opportunity to speak here today. I'm very happy to be partnered with the folks at DJI, and thanks for your time.